Hey there folks, this is Josh, Stoney Ridge Farmer. Welcome back to another beautiful day here on the Stoney Ridge Farm. Today's the day. It's the full install of the solar pumping system. And we have Eric from Lawrence, the Solar Water Pumping Company. Is that right?
You got it.
All right, so we're gonna be talking with you a little bit. And Eric came in today to help me kind of walk through the installation of this. Now, typically you guys have a group of contractors, or how does this work typically?
Yeah, typically we have professional groundwater contractors that are a network through the United States, and we accredit those contractors, we train them, and so on our website we basically show who has been trained by us to install our equipment, because we want somebody locally.
Yeah.
That way if you have a problem, you got somebody to call. It's not an internet company that,
Right.
you know, no sales, no support.
Right, so you got support,
yeah,
sales,
that's
and
right.
got this guy out today, so that was awesome. Thanks, man. Appreciate
Yeah,
you coming out
heck
and
yeah.
helping me out. That's super awesome. Before we even get started, we'll tell you guys where can they go online to look this up. Lawrence.
Yeah, it's Lawrence.de as in Delta Echo.
Okay, Lawrence.de. Okay, guys, so now you know where to go. We're going to go through the whole process here. We'll share with you what we're doing. First of all, the first step, we'll show you in a second. We'll walk you through it. All right? Woo!
I ain't afraid of work. I ain't afraid of play. I ain't afraid to get the job done and do it my own damn way. I ain't afraid of life. Times like this. If you mess with my freedom, I'll tell you just what you can kiss.
This is going to be a fun day, man. So if you're looking for a passive energy system, and that's what we're looking for, we're way off on a place on the farm that there is no power. There's no power line. And believe it or not, this direction is Energy United, and that direction is Duke Power. So we don't know what in the world we'd have to do to get power here, but I know it'd probably cost me over $5,000 just to get power up here to this well. So we scratched that, we went with the low footprint, and we're going with a solar system up here. And all we're doing right now is we're going to be installing just a simple hose bib. Eventually we'll be installing cattle waterers throughout the farm, but I just hadn't had time to buy them all, and it takes some money. It takes about 800 bucks a piece for those cattle waterers, and we'll be using Mirafount cattle waterers, and they are a no energy platform also, so we don't need to keep power running to our waterers. They stay thawed out throughout the winter just with the temperature of the water. So it's going to be pretty cool. Down here on our table and right back here behind us, I have a solar panel. How many watts is that solar panel, Eric? 200 watt solar panel. So we're going to be putting up 4 200 watt solar panels. We did get 8 200 watt solar panels, which is a ton of energy. All this is for is a tiny bit of irrigation once in a while if we have a really dry spell, and for watering our cows, so that'll be plenty. This system does not have a battery backup. In other words, it runs totally off of solar, so it's some interesting stuff. It's easier and cheaper and better on the environment to store water than it is to store electricity. So let's walk you through and show you all the parts.
This is a midnight solar lightning protection device that protects against near and distant lightning strikes. These are surge protection devices that protect our other sensors, such as a float switch, a level sensor, or a pressure sensor. This is our disconnect that allows us to shut down the power coming from the solar panels. The sun sensor allows us to make a setting inside the controller that tells the pump to wait to turn on until there's enough sunlight. This eliminates extra motor cycles and extends the pumping lifetime greatly. This is the PS2 controller. This is where we're going to take DC solar power input, and then we're going to output power to our DC brushless motor. And this controller has all the logics, all the communication. It can talk Bluetooth to a smartphone and does all the controls that we need to do, such as pressure, level, speed, flow. Anything basically that you want to do can be done with this controller. These are the grounding lugs for the solar panels and the bare copper wire to ground our disconnect, our controller, and our solar panels to make sure that any near or distant lightning strikes, static electricity, are dissipated to ground. This is a float switch. If we want to fill up a tank and have the tank shut down once the level in that tank rises, this is the piece that we used. This is a pressure transducer. It allows us to control the pump based off pressure. So if we want to use a mechanical float valve in order to shut the pump down based off line pressure, this is the piece that we use for it. These are our solar cable connectors. They're called MC4 connectors, and this is what's going to allow us to not touch any live wires, any bare wires. They're just plug and play male and female MC4 connection. In here we've got our stainless steel support cable. This pump is being ran on poly pipe, and this stainless steel support cable is going to be the weight cable that keeps the poly pipe from stretching And if the poly pipe were to break or something like that, that allows the pump to be retrieved out of the well and not cause any further damage. Yeah, these are just various pieces of hardware here that we're going to use to complete this and get water to the top and get it pointed to where we want it to go. This is our well seal, and that's going to give us a sanitary well seal so nothing can get down in the well that would harm the water quality. This is all the mounting hardware for the 4 solar panels that are going to be put onto this post that's back behind us. These will be 200-watt solar panels. They put off about 36.5 volts a piece and about 5 amps.
So this is what works the magic. It's already attached to the wire right here, and this will be about 200 feet down inside the well. This is a DC variable speed brushless motor that's 2.3 horsepower. It is a helical style pump, so basically it's kind of like an auger. It kind of augers the water out. Pretty cool little setup right here, and that'll all be ran onto that 1.25 or 1.25 inch poly pipe. Now this poly pipe will be ran out all over the farm, and it'll be feeding different waters. Again, for today's setup, I didn't have all the water, so we'll just be putting up a hose bib right here, and that'll keep the cows watered for now. Pretty cool. That thing is awesome. So the first step here is we're going to take all this hardware right here, we're going to bolt it all together, and we're going to be hanging solar panels, and there'll be 4 solar panels on this post right here. We were originally going to go with 8 solar panels, but we're going to try it with just 4 because we don't have much rise. As you can tell, it's not really hilly right here, so we're not pumping up, so we're not going to be burning that much electricity. We'll probably use the other solar panels for the other side of the farm for a hybrid system in the future. So be sure you pound that like button, subscribe to the channel. I'd love to have you back. We're going to be doing more fun stuff like this. Pipe up here is it's considered a 3-inch pipe, but it's actually 2 7/8 outside diameter. That's your cross brace. This is 4.5-inch outside diameter pipe. Okay, this pipe was a little bit small, but we made it work anyway. This is our fence pipe that we use here on the farm. So there is about 1,000 pounds of concrete in the ground right here. And we really, if you guys didn't see the video, I'll post a clip for you right now of how I welded a cross brace in here, because you got to think about this. This is going to have 4 solar panels, so it's really going to have a twisting effect if the wind gets to blowing one way or the other. So we really have to compensate for that by putting a brace or a foot on this post underground. Cool? And this is all bolted up with 17mm. Lawrence really thought about stuff and made everything the same wrench. Awesome. So the first brace has gone up here, and again it's held together by U-bolts, and we're at 40 degrees latitude, is that right? Yeah. So we'll set this at 40 degrees, and that'll give us a maximum amount of sun exposure. This is facing due south at 40 degrees. Now, we did put this up high enough to where we could graze the cows here and not have to worry about them getting into the solar panels. Maybe. So I'm probably going to go ahead and run a fence around this area right here. We've got some pretty cool new fencing materials we'll be using pretty soon on the farm. All right, time for the solar panel. Guys, so these solar panels are held on with these clips right here. We just push in on the backside and knock them into place with a rubber hammer. This is a dead blow hammer. We don't want to hit it with a metal hammer because we run a risk of damaging the solar panel. I'll show you. Slip this way as far as it'll go. So the next one of these supports just goes right up under, just the same as the last one did. So pretty much very simple. I can slide it over the end right here. Bring it down just like so. Lift up on the panel and slide it in right here. It's my first time doing this, guys. Very simple, very easy. You do need your rubber hammer a little bit to tap her into place. Same thing, same clip, backside, about 1 inch from the top. We'll tap her in. In looking at it, if we left this exposed to the cows, I think they'd tear it all to pieces, because the cows are constantly looking for a source of shade in the pasture. And this would provide shade and a good scratching post, so it'll definitely be behind a fence. Get you a time lapse finishing the rest up. So the next step here is we're gonna run a ground cable, okay? The ground cable is gonna run the full length across here, and we want to ground out each one of the frames for these solar panels, and we'll put it to a ground rod, which will be driven at the drip point on the edge of the solar panel. If you think about this, and I asked about this, well, where do we run the ground wire? Do we run it back up to this T and then back down the pipe? He said no, because that's going to be a drier area. You got to think about this. This is going to be shaded, and it's also going to be protected from wind and rain. So we want it to be in the wettest area so it gets the best possible ground, which will be ground fault protection in case of a lightning storm or something like that. Alright, so what we're doing right now is mounting the disconnect. The disconnect will come from the solar panels into the disconnect, out of the disconnect, and into the control panel. So this is the lightning protection device, and it'll surge to ground at 300 volts. So in case we get any kind of static or lightning discharge, it'll protect our pump. That pump is expensive. If you're working on this in the daytime, you've got to disconnect power, because anytime these solar panels are exposed to sunlight, even right now, they still have power on them. So you really got to think about that. You got to be safe.
What we're doing with Josh's solar panel now is that we are going to use MC4 connectors to keep from ever touching bare copper on these solar panels, because again, remember, they're producing DC electricity whenever the sun is shining. So we're going to use a 10-foot MC4 connector, and we're going to plug the negative to the positive connection here, and then we're going to run it over to the disconnect. And this wire is going to be hanging now, but we'll essentially bring it over here, and then we'll take a pigtail like this, and eventually we'll be able to plug in to where we've never touched bare copper.
You could get shocked and or electrocuted if you're touching bare copper that's coming off of these panels, right?
Absolutely.
Okay, good. So safety first. That's why we're going to do it with the pigtails coming out of the cold panel, and then all we'll have to do is plug it up, right?
You got it.
Awesome. Cool. Almost done, guys, and we're going to put the pump in. That'll be first thing in the morning. We'll see you guys first thing in the morning. Okay, day number 2. We're here on day 2, guys, and pretty much we left you yesterday after we got everything all wired up here. We've got a little bit of dressing up to do. We've got some zip ties to put in place here, heavy duty zip ties. We went on and pulled our pipe out right here, and we're gonna put this down about 200 feet. What my buddy Eric has got going over here is the well cap, right? This is the well cap. So, well seal. That's the pipe that's gonna come out. We'll have a pressure gauge right here on the top of here. And this is the pipe that's going to hold the poly that goes down inside the well. Now, we're not going to be solely supporting this well with the poly, is that right?
That's right. You get a stainless steel support cable to hold all the weight.
Gotcha, gotcha. And that's what this eye bolt right here is for, is to hold all the weight. See that eye bolt right there? The well is 460 feet deep. The gallons per minute are 10 gallons per minute. And the cool thing about this pump is you can dial it to whatever RPM or gallons per minute you want to do. So we're going to do a drawdown test on this. Is that right?
Yeah, you got it. We have a level transducer that's going to tell us how much fluid is over the pump, and
gotcha.
We'll see exactly how that fluid level reacts when we start pumping.
Awesome. And I can read this off Bluetooth. As long as I'm about 30 feet from this, I can read it off Bluetooth off the app that these guys have. So we'll always know how much water and how much drawdown we have, even in the driest time of year. Cool. So we're going to get busy working. So we've got our 200 feet of pipe measured out, and we're going to go ahead and install. This is 1.25" poly. So now we're going to run our power cable all the way out to the end of this 200 foot long. We already measured out 200 feet of poly. This is a sensor right here. This sensor goes down in, it'll be mounted right here to the shaft on the pump. This sensor will read how much water is above the pump at all times. And I can again hook to Bluetooth on the phone and come up here and check this. This will check the drawdown of the well. There are sensors in these little holes right here, and we want the torpedo to be facing downward toward the pump. It's time for a walkabout. We're gonna run this cable, the sensor cable, all the way out to the end, and then we're gonna run the power cable all the way out to the end. All right, Eric, how big a man are you?
I'm counting on you.
Yeah, this is gonna be a bear to wrestle, man. And our casing's up a little bit high too, so it's gonna be fun. 200 feet, what did we say, 200, 225, something like that's what we measured off. So we'll start dropping her down in the casing. Bye-bye well pump. See you in 25 years. Guys, what you can't see here is that this pipe is trying to float up out. So we're having to really push down hard in order to keep it from floating back out. As it fills with water, it'll pull the pipe down. So we've got everything rigged up. Solar panels in place, everything's set up. We've got enough cable to run over here to our control box. We've got a few other things. There's a little sensor, you can see this blue thing. It's a little sensor that Lowrance does special to save your pump. In other words, that senses light and lets your pump know that there is enough light outside to engage your pump fully, instead of halfway engaging it and reducing the life of your pump. So this is all about saving money, saving time, and saving electricity, and keeping your pump in as good a shape as you possibly can for as long as you possibly can. Now we've got this supported with the bucket. Poly pipe is slowly filling up through the pump, okay? So it will get heavy and it will start to pull down on here. We've got a T here and we're gonna go ahead and run some tests. We're gonna pump and we're gonna see how much water we're pumping out, where the static level stays in this well. So we're wiring up the sensor right here. A point to make, guys. So a lot of your less expensive pumps that you find online, and you'll find them less expensive than the Lowrance pump. But the Lowrance pump makes a lot more sense because all this electronic gear is in the pump in a lot of other applications. And if you have a circuit board problem, you're gonna have to pull your pump out and just replace the whole pump, which could be $2,000 to $4,000 to $5,000 versus replacing a $40, $80, or a $400 circuit board up here. And it's all surge protected right here too. So we got protection here in 3 places. You got surge protection on your circuit boards. In other words, they're all separate from the main board, and you have surge protection out here. So a lot of protection built into this system. So here's where we get scientific here. This thing has Bluetooth connectivity and it has firmware. It'll update itself via Bluetooth, and this is Eric's phone. So we have our voltage, all of our information right here. So our voltage is 170, our controller temperature outside here is 77 degrees, and our water level is at 163.7. So that's just about right for the 200 feet that we dropped down. Woods Groundbreaker did an awesome job. So frost line is 18 inches around here. We went about 24 just to do a little bit of overkill. We're gonna put in a frost-free hydrant right here, and that's what we're gonna run temporarily until we get our watering set up. Rad. Put little T to work, little dirt pusher. All right guys, what do you think? Awesome, huh? So the whole solar setup is all done right here. Again, this is from Lowrance. This is Eric with Lowrance. Thank you so much for all your help, dude. What a huge help, man.
Enjoyed it.
To have him out here and to be able to show you guys and educate you guys on just how a solar well pump system works. So we'll talk a little bit more about this system here. So this is an on-demand type system. In other words, it will cut on, it'll cut off, it'll do what it's supposed to do in the daytime. In the nighttime, it won't do anything, okay? So it's cheaper to store water than it is to store electricity. So what we're gonna do is we're gonna put a water tank associated with this, and cows aren't gonna be drinking all night long anyway. So that's the thought process here. Totally energy-free water system. Now, all we have is this frost-free hydrant right here for now, and that'll get us through the summer, and hopefully in the fall we'll start putting in our mirror fount waterers. It's gonna be awesome, guys. We got about 10 gallons per minute at about, how many PSI?
set at 30 to pick off 30 psi.
About 30 psi. So awesome, guys. Thanks a lot. Please pound that like button. I'd love to have you back here on the channel. We'll give you a whole lot more updates and stuff. I've still got a little bit of dirt work to do, but I got to get Eric to the airport, man. See you guys later. Thanks a lot. Eric, there's one thing we do at the end of every video. All right. Woo! Woo! Come on, you're from Texas, man. You got to do woo! Woo! Good stuff. See y'all. Thanks a lot. Hope you enjoyed the video. Man, this was a great time. What a fun time today. See you next time.
Down to the Stoney Ridge, bring your wife and bring your kids. We're living life pure and sweet. That's the way it's supposed to be, Stoney Ridge. Woo!
Tighten bolts and Lawrence. Just Lawrence and repeat. Eric's rolling his eyes back there behind the camera. This guy's full of crap. We're building a swing set today, kids. Make a heck of a swing set, wouldn't it?